We're going to round off the meeting with a bit of a panel discussion, and actually Sophia came up with the theme for this, I think, but it sort of resonated. What we find now is that AI and data science technologies are really kind of increasingly pervasive in life, and they've become very much something that has to interact with human users in real time, and impact on humans, and can be enhanced by working well with humans, and so we thought we could have a panel discussion about sort of the cooperation and coevolution of human and artificial intelligence as a more kind of combined system, and discuss a bit about the interactions between human and artificial intelligence. So we've got three people in the panel. So Sophia Ananiadou, who is the co-director of the Institute for Data Science and AI, and also the director of the Text Mining Centre in Manchester, NACTEM. Isabel Valera, who spoke earlier, and Samuel Kaski, who spoke earlier. So those are our panel members, and each member of the panel has prepared one slide just to start things off, and they're just going to talk briefly to their slide. And then as people listen and think about what the speakers are saying, they should post questions into the Google Doc, and then I'll ask the panel members the questions. So if you have a general question, just put the question in. If you have a question that's specific for one of the panelists, then put their name when you put the question into the Google Doc. And I think everybody should have the link to the Google Doc. So I think to kick things off, perhaps Sophia can start and share her screen and the first slide.
Okay, just a moment. Okay.
And it's very late where Sophia is. What time is it, Sophia?
I don't know anymore. So it's best not to think like this. So it doesn't help. So okay, this is like some thoughts about the coevolution between human AI, slightly philosophical, I guess. Of course, human intelligence is really a combination of explicit, symbolic, and tacit knowledge, and I'll talk a bit about that. And AI intelligence currently is based on a lot of big data, and it's considered a lot like a black box. So currently, these two realms of human and AI based on big data, they are basically are completely different. And what we are trying to do is to try to bridge those two basically spheres. So I'll just talk a bit about that. So currently, of course, AI is based on big data and on machine learning. And so what we do, we observe the real world by data, and based on the data, we build models of the real world. So from big data via machine learning, we learn the models. And based on the models, we make some predictions, we take some actions in different domains. But all these observations, again, they are partial. So all our big data is always partial. If we go to the human intelligence, again, it's even more limited observation. So of course, humans observe, but our experience and our actually knowledge is quite limited. But we have something else that AI doesn't have. So we have education, we have formal education. We can make, we have a kind of whole body of knowledge behind us. We can make hypotheses about different mechanisms. And all this accumulation of human knowledge is extremely important for humans. So the individual human cannot observe everything, but if you have the body of evidence from collectively, it's quite interesting. So nevertheless, so we're talking about explicit and tacit. The explicit knowledge that we have is basically, we can verbalize the knowledge, like for instance in text, but it's also the explicit is we are self-aware of the existence of that, the existence of that knowledge. The tacit is actually lots of knowledge that we have in our mind, which cannot be verbalized, and that's actually the difficulty here. So we know it through experience, through small observations, through trial and error. So that takes us to the different models that we have, the learned model from the AI and the conceptual model. So for the humans have a conceptual model which has this explicit and tacit knowledge. So previously in the older days, AI was slightly more explicit. We had rules, but this has been abandoned, of course, and we have these big black boxes. It doesn't, so currently AI doesn't have this kind of explicit knowledge, according to my interpretation at least. So what we are trying, what is the preoccupation of currently this coevolution is how we can link these two types of intelligence of human and AI. And here is basically the middle, that we have a new framework of AI, so different technologies. So first is simulation. So for instance, how we can do, for instance, experiments, physics without having experiments. And simulation is very much based on our explicit knowledge. But at the same time, we have also knowledge, and we have knowledge graphs and ontologies and rules. So which are quite also important in our case. So this helps us to do inferencing. It's again another type of AI. Those two guys are in the middle. Which take us to my last point about explainable AI that people are talking a lot. So this is basically the link of what is happening basically inside AI in terms of explicit knowledge. And the ontologist and the presentation is basically trying to do that. So to sum up, human intelligence can be more integrated into the AI through, say, simulations, through explainability. So this is how we can bridge from AI to human. And in a sense, both spheres, they're defective, they have defects. So by trying to integrate them, we can remedy each other's, basically humans and AI's defects. This is my pitch about the coevolution on human and AI. So
great, thanks, Sophia. Okay, let's move. We're just going to move through each person and then have the discussion at the end, I think. So perhaps we can have Isabel next, if Isabel's there. Can share screen.
Is it visible?
Yeah, that's good.
Great. So I'm definitely not an expert in collaboration of human and AI. I most of the times work more in the direction of how to explain AI to humans. But I believe, and actually in the ethical questions that arise, but I think that there are a lot of things to be discussed. And I'm going to focus mostly in my area of expertise, which is decision-making or consequential decision-making. And of course, the first question that arises is whether a decision like retrial bail should be made by a human or by a machine, or even better, why cannot we get the best of the two worlds? So as Sophia was saying before, maybe the human has more complete information about the world or about the individual, but on the other side, we know that algorithms can be much more precise in solving some tasks. But of course, the problem that arises here is how do we combine these two? So for example, I place here an example where we have a human decision maker and an algorithmic decision maker, and they disagree in their recommendations. So the question, for example, would be who overrides whom? And how do they arrive to an agreement? And for that, of course, they need a communication, they need a common language where they can communicate with each other in order to get an agreement. But the problem, some of the problems that arise there is that when we would be able to combine humans with machines in order to make such decisions, which have consequences in people's life, not only the problems that we know that arise in standard algorithmic decision making, like explainability or human and AI biases show up, but problems like accountability, who would be responsible for making that decision, or how do we make the system transparent would show up, together with the fact that, for example, there would be feedback loops that will be included, where we iterate through this communication and maybe the human adapt to the algorithms or in the other way around, and how do we account for these feedback loops so that, for example, if there are biases, we don't amplify them, which is a result that we have seen before. So basically, everything I wanted to point out here, that is my personal opinion, is that if in general, when we have algorithms making decisions, we encounter a lot of ethical questions, it seems to me that whenever we are going to aim to combine them, probably we are going to encounter not only the same ethical issues, but even more than we had initially. And I think my proposal was a bit shorter.
No, that's fine, Isabel. It's supposed to be discussion, so it's good. You've interesting. So how can human and AI systems work together in this kind of area? Excellent. So, and the final presentation is going to be from Samuel Kaski. So, Sammy, if you can share your screen.
All right. Is it visible now?
Yeah.
Okay. So I thought, because this is so broad question, I thought to bring up just one specific issue in collaboration between human and AI is what are the assumptions that the AI makes of the humans, and how does that affect how well the collaboration would work? So starting from the stereotypes, maybe a stereotypical way how human-computer interaction papers consider AI is that they consider AI as a black box and a very simple passive black box. And in contrast, in machine learning papers, often if there is a user involved, then the user is completely passive. It's just a human in the loop who provides maybe labels in active learning. And of course, the real systems need to make more assumptions of the user in order to be useful. So from the completely passive ones in the top, what standard systems do is they collect information for user profiles. So kind of general preferences of a specific user, like in recommendation engines. If I search for similar stuff many times, it makes inferences that I'm typically like those kind of things. And then if it suggests something else, it needs to be exploration. So in my talk, I gave a couple of examples on us humans obviously being active. So we are doing planning, And if the AI has a representation of us as planning agents, goal-oriented but imperfect planning agents, people talk about bounded rationality or computational rationality, with the idea that our plans would be represented in terms of their goals that can be expressed as rewards or in terms of rewards, or then simply as in terms of goals. And that we've given our constraints coming from our cognitive limitations and the time we have and so on, then restrict how optimal we are towards those achieving those plans. So this would be the next step. And then the last step would be, which I believe is important in getting really collaborative, kind of online collaborative system going, is that both parties, in this case the AI and the user, understand that the other person or other agent has a representation also of me. So why am I suggesting something? If I say something, I probably have an intention on where I'm going to lead the discussion, and the discussion will be much more fruitful if the other guy considers what I say in this sense, instead of just bringing up topics like a recommendation engine, for instance. So to sum up, why am I bringing this up is that I think this is one really important bottleneck in why the user AI, human AI collaboration is tedious at the moment, and which we could fix. Yeah, thanks.
Excellent, thank you. So, okay, so if people have any comments or kind of response to those statements, then please put them in the Google Doc and I will take a look at them. I think I'll kick off because I wonder about the link between what Isabel said and what Sammy said in a way, because so Isabel's talking about the difficulty of integrating human and AI decision-making, if you like. So, you know, what happens if you have a legal or a medical system which has a human aspect, so it could be a judge or a doctor, and a computational aspect, so it could have an AI aspect to it. Or it could be some engineering thing like a driverless vehicle, perhaps, where a human can override the vehicle. In those kind of situations, can some of the issues be rectified or improved if the AI models the human to some extent? So we talk about the difficulty of humans modeling AI, which is sort of interpretability, and humans being able to understand how the AI works. But what about the other way around, which is perhaps what Sammy's getting at, where the AI has to kind of model the human, and can that help? So maybe I'll pitch that one at Isabel and ask whether thinking of it like that can maybe help resolve, you know, whether to use the human or the AI in these kind of situations. If Isabel is there.
I am here.
Hi.
Okay, so it is hard to tell. I think it should be possible, and definitely having a human representation on the machine that understands the machine somehow understand better the human, as Sammy was proposing, could help. But we also need to be very careful, because if we learn a model of the human, this human is going to have some particular biases, right? And we might not want the machine to adapt too much to the human, because we might want the machine to have a different point of view, like calling a different expert into the topic. So how to trade off these two parts so that we have representations of the human that allows for better communication, while at the same time not to adapt the algorithm too much to the human, so that it adds some value to the discussion, I guess is something highly difficult to measure, but maybe Sophia and Sami, they have a better intuition of how to do so.
Yeah, I'd very much like to respond to that, if that's okay.
Yeah.
So maybe if I would start from a completely different kind of an example. I understand, Isabel, that the kinds of applications that you have in mind, if you have judges there and so on, they are completely different in many respects than, for instance, the self-driving cars. But in the self-driving car, the kind of modeling of the human I would consider here is that kind of understanding what the human is doing right now. I mean, now the fail-safe systems at the moment are where if the AI is not able to handle the situation anymore, it transfers the control to the human, which is a disastrous idea if the human happens to be looking somewhere else and doesn't have the hands on the driving wheel, right? Mm. So that would be one example where it's absolutely necessary to have a model of when does it make sense to transfer. And of course there are other actions so that can be taken. So first alert in a way that the driver doesn't get scared, and then they may be able to take over in this case. So when adapting with to the humans, I wouldn't necessarily, in your cases, I would not be proposing adapting to the content, right? It would be to adapting to present the case, for instance, in a way that is easily understandable to the judge, digestible to the judge, but of course not sacrificing the content, not tuning the message that do whatever you please. Then of course the AI wouldn't be useful at all. Yeah, I think it was a good point.
We've heard a lot about bias in AI and machine learning recently, and it's clear that there's a lot of bias built into AI systems through data set choice, and you know, you can basically train a machine learning system to have lots of biases that are undesirable. And we had a talk in last year's conference about policing and the quick uptake of automated policing systems in the US. Leading to some, you know, racial bias and other types of bias in the data, because the data was trained on policing practices which were probably already biased. But Isabel, what you were talking about was, but also the human systems are biased. I mean, that's why the machine learning systems are biased, right? So in that policing example, you know, this is a hot topic at the moment. Clearly, the human system itself has lots of biases. Do you think that we can actually, in a more idealistic world, the AI can improve the human system if we think of them together and actually kind of reduce biases in those type of systems? And are there any examples? Are there any kind of good use examples, or is this just a pipe dream that will never actually happen? Has anyone deployed something that made a system fairer and more, you know, better, a human system, through use of machine learning or AI yet?
Well, so I think there is definitely room for improvement and for this kind of collaboration. And in fact, from a couple of years ago, or 3 already, I have some work where we think of fairness and machine learning the other way around, and we use machine learning to make a human decision-making system fairer by doing an assignment between the decisions to be made and the individual humans making the decision, in a way that you try to correct for the biases, because over the time you can learn the biases of the, for example, the judges, and then you could assign different cases to different judges so that the overall court is statistically fairer, right? This is something that we proposed a couple of years ago, and I believe it is also something that even when we do the assignments of reviewers, in our conferences, there's a bit of automatic behavior behind that try to add some level of randomization, that in general randomization we have some that helps also to correct some biases. Whether they have been directly implemented, I guess there would be some industry partners that can answer that questions better, but I would be surprised that even if at a small level they haven't.
I mean, I suspect in medicine, there are probably examples where automated systems have improved things and corrected for certain biases, which might not be insidious biases. They might just be poor training or whatever among doctors. I was interested in your legal example. Did any judges end up never getting any cases? I mean, I think there's some judges in the UK definitely wouldn't get any cases if you wanted to optimize the system. So I guess then you could use a sparse system to sack them or something. To sort of go back then maybe to more what Sophia was talking about, I think Sophia's presentation was more about like the different styles of model that humans and AI has about the world, and different types of knowledge that the AI system is able to kind of leverage that maybe that AI systems don't. And I was kind of thinking about the driverless vehicle case. It's very hard for driverless vehicles to have all the background knowledge that humans have. You know, so you're kind of driving past a school crossing or something, and you see something at the corner of your eye, and you have a huge amount of prior knowledge about that particular situation, which is presumably never engineered into these systems. I don't know if Sophia wants to pick up on that, but I guess
I mean, as I said,
the depth of what may seem completely unrelated knowledge, but may come to play in 1 in a billion chance.
That's correct, and also that's why I think that these two. Our AI systems right now, always in the human, there is not, our representations, as I said, they're not very well understood, specifically because we have so much kind of collective knowledge who comes, this tacit knowledge, which is not specifically verbalized and comes to play in planning and actions. And I think we're getting there in the end. And that's why I mentioned as an example simulation, because that's one way of picking up both the human brain and learn from humans, but also simulation is really based on our explicit knowledge. So I think we will be converging. We will try to pick up and correct the deficits, basically the lacuna that we both have as humans and the AI systems, to self-correct each other. I don't know if that makes sense. So you have a kind of this virtual world which is validated through simulation. That's an example. But your example of the car is that you know, as we are learning as humans by trial and error and small observations and experience, this is how these two types of knowledge will integrate it with the AI and human knowledge. So I mean, I guess, yeah.
So to pick up on that, I mean, it may be fanciful, but the driverless vehicle thing is always, you know, don't switch off the car and start driving it. As Sammy said, that's probably a bad idea. You might be asleep. But the vehicle could interact with the human in other ways that are less risky. And it could, for instance, ask the human questions, or it could, and I don't know if anyone is doing things like that, or if there are any systems like that, but where where the AI has to know what it doesn't know in order to extract useful information out of the human. And I think in medicine that would also be very useful.
And most probably in self-driving cars, actually, I should have picked up that here, because in the AI center here in Japan, they're working a lot on self-driving cars. I should have asked them about this, but I didn't. So most probably, yes, I guess this is how their example is very good. Most probably you're picking up what you correctly said before about, when you have the human in the loop, the car as an interface, you have an interaction between the human and the machine, and you're picking up from that. So the human in the loop is extremely important in picking up. And actually, we're kind of sort of trying to verbalize our knowledge into the machine, which is picking it up. Yeah, it's quite perhaps a way of looking at it.
I mean, I think so Isabel, you were talking a bit about legal system. At the moment, do you think that there's enough investment in new legal frameworks in this area? Because my understanding is that it's not, that as we get these integrative systems that involve humans and AI, it's going to open up whole new areas of law.
I mean, I believe it's already triggering a lot of discussion within policymakers, and they are trying to open the discussion to researchers in the area of AI and machine learning in general. And if we look at the funding areas and at some of at the research level at least, how much money they are investing in these topics, whether it is enough or not, I'm not sure, but definitely there has been an increase in the investment, right? I guess maybe the problem I see nowadays is that most of us, we work in one particular area, and having interdisciplinary teams outside industry tend to be quite difficult. So if you work in a university, or even if you apply to some of the research funding that are available, when you don't identify yourself as a pure machine learning or technical person, or as a pure social scientist or policymaker, things become difficult. While I believe we would all benefit if we could encourage these interdisciplinary teams from very early in our career, so that the people can develop a common language, because this is one of the main problems you encounter when you try to work with lawyers, philosophers, or policymakers, or even doctors at times, that it takes you a long time to be able to speak the same language, and you need to do a lot of extra effort.
Yeah, actually, one of the best candidates we had for the Turing Institute AI PhD competition last year was a lawyer who was coming to study law around about AI, and I thought she was excellent, but she's going to have a tough time because it's going to be difficult for her to mix with all the kind of machine learning people at the Turing, I thought. But I mean, it's great to have people come in from other disciplines. There's some questions now on the Google Doc. I was neglecting it because I was getting into the discussion. So Harry Chan has asked, who should provide ethical and moral knowledge to these algorithms? For example, should we just include idealistic Western standards? Which moralities are considered the best? This is a tricky one.
I guess that's also, I think knowledge is very much, as it is domain dependent, it's also culturally dependent. And there is no such thing as one view, obviously. So I think I can say there's no ideal about ethics, but it can be customized. The same way when we are doing natural language processing and we're building system-specific domains, say for medicine or law, you have a very cultural environment, which is plays an extremely important factor. So my question is that there's no such thing as Western or non-Western. It's very much culturally as it is domain dependent.
Mm. Let me,
or
because,
sorry, or it could be hybrid. Yes, can have both, an amalgamation of both.
definitely a tricky one. So let me move through these because we have to close. So I want to get through all the ones that people posted. So Danielle was asking, what ideas do you have for improving transparency of ML analytic models? What's your opinion around creating trustworthy ML models? What do you see as a trade-off between accuracy and interpretability? What are guarantees that domain experts and end users trust ML models, especially where these models are black boxes? Before I put that to the panel, our Center for Health Informatics here, and I don't know if any of the members are here. I think some of them were here earlier. Did a sort of citizens jury to ask about explainability in medical prediction models. And there really people were more, when things were unexplained but more accurate in terms of medical prediction, people were quite happy. Or rather they were more interested in having high quality predictions than explainability. Whereas I think in other areas, the trade-off is different. So I guess it depends a lot on the area. I guess, Isabel, this is kind of your area.
Okay, I'm getting a lot of work in this panel. Definitely, that depends, like almost any ethical concern on machine learning applications on the special domain where we are applying, and also on the general agreement that the society locally or globally has arrived there, because commenting on also on the previous question, usually laws are local, right? And they are developed locally, so definitely we need some flexibility there. The right level of interpretability or transparency, well, this is up to discussion, but even when the decision is made by a human, I don't think we have a fully white box, right? It's sometimes you are not even able to explain your own decision fully in a completely rational way. There is always a bit of randomization. And I guess what we need to arrive is to an agreement of what are the criteria that are gonna allow us to trust the system, because with a human we empathize because we are another human and we know how more or less we make decisions, and you trust experts on a topic. So what would you think that a machine, how would you classify a machine as an expert on a topic enough so that you can trust under some decisions or under some predictions, right? And all these are definitely open questions. Whether we need a completely white box or even we need to even trade off between interpretability and accuracy, it's not even clear to me. There are many methods that don't even touch the algorithm in order to provide explanations. But simply the explanations that they provide are more at the input outcome level without going in detail of what is in between.
Like which data was used and what are the kind of biases of the method and that type of thing. Which I suppose in that case, modeling the human decision makers can be equally useful in explainability, because as you say, humans either might be hiding or might simply not understand their own biases in their decision making, and I guess we want human systems to also be kind of explainable as well as AI systems. Let's see. I don't want to ask the same. I'm trying to work out what the other questions. Okay, well, maybe a final one. Well, it's kind of related because it's from Harry again, which was it was basically to do with transferability across countries, I think, in kind of this decision algorithm. So I suppose it's more about legal decisions in different countries and different jurisdictions. I guess again, this is to do with differences in cultural biases and differences in different. I guess legal law is very kind of dependent on different countries and jurisdictions anyway in general, right? I mean, that's not specific to AI. So I'm not sure. I'm just having a look at the time here, and I notice we've kind of probably gone over. I don't know if anyone on the panel wants to say anything to finish, or if there are any points I didn't pick up on.
Maybe I could say a complementary point to Daniela is the that how to improve transparency. So it would really be a pity if we would have to choose between having models that we completely understand and models that are accurate in predictions. I know very well that I don't understand all models, and I don't want to understand all models. I'd like to have an AI assistant that helps me on the things that I'm not good at. So that's maybe where also this user modeling can come to help. So we could have an AI that tries to help, tries to explain to me in a way that I can understand, and tries to teach the actual criteria to me so that they are kind of take minimal effort from me.
And I think there are things that are not understandable, right? So I mean, if you have a model of a physical system, you know, which is a complex, you know, requires complex Newtonian dynamics or something like that, and it explains how something works, how an airplane flies, or how some turbulence happens. This could be an excellent model that is not actually explainable in any human sense of the word, because it's a, you know, it's a model of a complex mathematical object. So I guess that, you know, some things may be inherently not that explainable, I suppose, in terms of modeling and simulation. We can simulate very complex systems. Does it mean we can explain them? I'm not sure. I mean, just because you can simulate something, what does understand mean? Anyway, I think we've probably reached the end of that. Thanks to the panelists for that. I thought that was really interesting discussion. Great to hear different views on this. I think the integration of human and AI systems is going to be a big thing going forward, and I look forward to sort of seeing what happens in this space.